So let's get started then. Welcome everyone. We have a great group of people here from around the globe. Um, Pun intended. But we are actually starting off the second phase in our Trees Around the Globe student research campaign for year 3. And this is really focusing on um, taking the science that we did from the first phase, looking at the 4 different protocols from tree height, land cover, carbon cycle, and greenings. And we're going to focus now for the next 3 months. So today, the February 9th webinar, which you've probably got an invite for already, and then the March, from which we haven't decided what date we're going to do that yet. But we're going to focus on, what we can do to help out in, helping students to develop student research projects, assist along the way when we can, show some examples, and and show some ideas of what can be done. And along those lines, what's important here is that we have some presentations from some students today who have been doing research, doing data collection research, and looking at the globe data. And they are going to be presenting today from Malta and the Philippines. So thank you for their dedication, because in Malta it's about 8:00 p.m. and the Philippines it's about 3 a.m. So, and then we're going to focus on some things. We're going to build upon what we've talked about before with story mapping and looking at satellite data as compared to ground-based data, and imagery, looking at online tools as well, to go a little deeper into what we're going to do. And then next month in February, the February 9th webinar, we will go even deeper into some of these things. So let's get started here. I'm going to do a little bit of introduction. Here's our core campaign team. I'm Brian, Dorian, Peter, Christopher, and Peter Falcon are all part of the campaign team. They are all on with you today, and then we all have really vital parts of each of the webinars, specific sections, but it's how we tie all those sections together is what counts, and that's what we're doing with every webinar that we do, and today will be no exception. So today's webinar agenda, right now we're in the introduction. We will have the student research presentation from Globe Malta at the St. Michael's School, and it's mapping and measuring trees in St. Michael's School with students Ben and Terrence, and the teacher is Mr. Joseph Savona. And then we will have Dr. Christopher Schumann talk about the trees in the news, how staying current on trees news can be important to your research, and he'll be focusing on DeSoto National Forest. And then we'll be having 2 more student research presentations, and these are shorter presentations, informal, 5, 7, 10 minutes, somewhere in that time frame. And then student research presentations from the Globe Philippines, and we have one presentation, a case study evaluating the correlation between urban heat and tree height in Quezon City, and then tree health assessment in urban and rural areas from the Bodison Hills National School, both of these from the Philippines. And then Dorian will take you through a review of StoryMaps and build upon what she's done in the last several webinars to include how you can include this in your student research as the basis for the student research, or if you just want to do part of your student research using StoryMaps, Dorian is the person to definitely talk to. And then I should mention, in the next webinar in February, Peter Nelson will be talking about some specifics about creating maps and doing mapping in StoryMaps, looking at it a little more technical aspects of the story mapping and creating maps that go along with the story maps in your research. And then I pre-recorded a webinar interactive, and it's basically looking at a satellite image, how you can look at a satellite image and it could be satellite image, it could be a drone aerial footage, it could be an image from aircraft, but what the image can tell us about trees, land cover, greening, just by looking at an image. Okay, and then I have a video. It's about an 8-minute video recording where I go into talking about looking at an image and then going into places like open altimetry and into the globe database, into the globe visualization system, to then grab the same location from all these different areas so that you can do comparisons. And this is the way you can do research. You can look how the data correlates with each other when you're looking at the satellite data, when you're looking at the globe data, and when you're out in the field taking these measurements. And then we will then have a discussion on the importance of online tools for student research, basically, how do I know which online tools to use? I know some of you may be confused with that because there's so many online tools out there. And what Peter Nelson has been trying to do done over the last, you know, even just in year two, towards the end of year two and all of year three, is to highlight some of the really important online tools, some of the most usable online tools with the best, user friendliness, to take those, the information, the data from the ground, from satellites, and do these comparisons so you can see this whole thing visually, so you can visualize all this stuff. And when you visualize all this information, it really, pushes your student research to that next level. And then at the end, we will have an open discussion with some questions that that have been asked of the team, and we will go over some of these guided research questions because they may help out. And anybody else who has any questions, along the way, please put them in the chat. But in this section at the end, this is going to be 10, 15, 20 minutes, depending upon how much time we have. We have this webinar set up for 90 minutes. But we're going to, if you have any questions specifically about your students and doing the research, any questions, any ideas, or any concerns that you want the team to help out with, or you like to hear what other people on the webinar are saying, what advice they have. Maybe some of the students may have advice, or some of the teachers who are on, the educators, have some advice as well to some of your, or some answers to your questions. So let's go ahead and quickly run through some metrics here. The metrics, as I usually put together, we have all the way at the bottom, we have over 62,000 measurements from over 24,000 global sites just since the campaign began. As you can see here, we're over 27,000 tree height measurements since September 15th of 2018, when year one started from the campaign. We have over 17,600 land cover measurements and over 17,000 green up, green down measurements. So we have a lot of data there. So even though right now, we're in the middle of a global pandemic, some countries, are on lockdown. Others are, really taking steps to mitigate this and try to, get rid of it. We want this pandemic, we want the COVID-19 issue to be gone, right? We want it to get out of here. We're tired of it now. So what we do say is, we don't want to tell people you need to go outside and take measurements. So as Globe and Ivss for this year, Ivss 2021, is really focusing on data literacy. If you can't get out and take that data, if you don't feel safe going on and take the data and you can't do it safely, there's lots of data in the Globe database. And this is why I show this each time, because there's lots of data in the Globe database, probably for your area, your fellow students, or, your students from the past. If you're a teacher, may have taken this data at one point, around your school, around their neighborhoods, in your location. So this is a super time to go and look at this data. Okay, and there's lots of answers you can, or questions you can think of to come up with answers to research projects. So here we have this again. Here's where all the data is coming from. This is a graphic that you see each time, but this is for the life of the campaign. You see it's coming from all over the world, so there's lots of data out there. So as I mentioned, first thing, we are in the second phase of the year 3 scaffold structure for the campaign, and that's the science and planning student research. How do we take the science that you learned in the first quarter, September through December? What do you do with that science in order to create student research projects? And that's what we're going to start really talking about today during the webinar. So without further ado, I'm going to introduce student presentation from Globe Malta, and it's mapping and measuring trees in St. Michael's School. And the students are Ben and Terrence, and the teacher is Mr. Joseph Savona. And what I'm going to do now is, bear with us here, I'm going to stop sharing my screen, and I'm not sure if the teacher or one of the students is going to share the screen, but I'll go ahead and stop sharing, and you can go ahead and share your screen and start your presentation.
Okay. Welcome from Malta. As you already know, we are students from St. Michael's School, which is located in St. Vener, which is quite an urban place in Malta. And as you can see on the next slide, our school is actually surrounded by a lot of buildings. The only trees that is actually the property of the school is the line of trees that is near the school, and the garden over there so behind the school is not the school's property. We as a school use a lot the Globe Observer, which we found very useful, and it was very fun because it helped us a lot to learn, and we found out a lot of great stuff. The Globe Observer, we used it by first we located any tree that we wanted to use, and used the app to measure the angle between the bottom and the top part of the tree. Next, we photographed the tree and counted the number of steps it would go till the bottom of the tree and took a measurement. Then we also measured the circumference of the tree using a measuring tape, and finally we reported the weather conditions, if it was maybe sunny, if it was cloudy, if it was raining, etc. Now, on the next slide, we, with a school, we identified around 10 trees, and Terence is going to talk to you about 3 of them.
In our school, there are 10 indigenous trees that are in the Mediterranean region. Indigenous means that they can live in a specific type of climate. In the Mediterranean region, it is a very dry place, and in Malta, which is surrounded by sea, there's a lot of humidity. So these can live in a very dry and humid places. These are the olive tree, carob tree, Judas tree, cypress tree, sandred gum tree, which is our national tree. You can only find this tree in 2 other countries, which are Monaco and Amsterdam, I think, and an evergreen oak tree. But there are some non-indigenous trees in our school, which are the Norfolk pine tree, pepper tree, yucca tree, and cinnamon tree. A lot of these, under the tree, nothing grows because they are not they don't live they don't live in dry places, and they may be toxic to other plants. With all this data that we got from the trees and mapping, we are going to put them in a video, and we are going to name the trees after the students that helped mapping and you giving data, and we are going to form it into one video, which helps us know about the trees that are around the school. Thank you guys for listening to our presentation. Hope you found it interesting, and you have a good night from Ben and Terence from Malta and from the St. Michael's School, Santa Venera.
Thank you so much, Ben and Terence. So when you did a lot of your research, did you were you able to contact anyone in Malta outside of, your teacher or other students? Did you work with any other students or people in the community? I know, it's a little tricky right now with the pandemic, but were you able to talk to anyone?
We were able to talk with students in our school, but apart from that, we didn't get the chance, unfortunately, to talk with other people outside of our school.
Thank you. But that's good that you're talking to the other students as well. Yeah, and I'll reiterate what Dorian said in there. We're all looking forward to seeing, what the final research is. Dorian, I know, is especially excited because of the story maps that you're going to include. Does anybody have any questions for Ben and Terrence?
This is not a question, but I was really fascinated with the tree that you showed the pictures of that is only found there and possibly in Amsterdam. Really, really neat. And that's nice that you pointed out the difference between your native trees to your area. Yeah, that's just amazing. So really looking forward to seeing your final story map and the results of your work.
Thank you.
Thank you.
Anybody else?
Yes, at first I want to say that I suppose Malta is a very nice country. I would like to visit it once. And my question is, what is the height, the tree heights around your school? What is the height? The tree's height? Because you use the globe observer to measure it. Can you hear me?
The tallest tree, it isn't indigenous. It's not an indigenous tree in the Maltese island, but it is the Norfolk pine tree. It is the highest tree in our school. It is more a little bit less actually than 3 stories high.
Okay, thank you.
Which tree is the hardest? Oh, no, hardest is the which tree is which tree has the most of this weight? Hello?
I think there might be a little delay in the response. I think the question was, what is the not the tallest tree, but kind of the largest tree, which might have the largest trunk and size wise among these four?
I actually think that it is the Aleppo and the pine tree, the oak tree, the cinnamon tree, which is actually quite large, and I actually think that it is the heaviest tree in weight, but I'm not 100% sure.
Thank you.
That might be a good thing to add to your research to find out which one. It's kind of hard to measure how heavy the tree is, but you could potentially measure the the circumference of it. At a couple meters.
Sorry. Sorry, I asked a wrong question. Heavy. I didn't remember that word.
Yeah, it's okay. Completely understood. Understandable.
Thank you.
Yeah.
Thank you, and on answer.
May I ask a question?
Of course.
Okay. So there are different species of trees like pine, pepper, and cinnamon. So mainly these are some hot and humid climate bearing trees, but pine is generally we have a concept here in Pakistan. It's in the highland. It's available in the highland areas. So does the climate of Malta, it supports such diversity of trees to be grown at one place, or different periods of time they support their growth in different months, or it remains the same sort of climate that supports the growth of all these diversity in tree species? I rephrase my question. There are different types of trees that you have shared. So Malta is supporting, Malta's climate is supporting the growth of these different types of species equally? This is my question basically. Because for us, pine tree is mainly available in the highlands, and pepper and cinnamon, these are mainly in the hot and humid areas. So what sort of climate that is there in Malta that supports such diverse tree species?
In Malta, the Norfolk pine tree, which is one of the first trees that was planted in the school. There were 4 trees before, and now only 1 is left because there were some projects and they were cut down, unfortunately, and one of them survived. It always stays the same because the climate doesn't change that much. Right now in winter it's very cold, but it always stays between the same temperature. But in summer it becomes a little hot. But some of like pepper tree and cinnamon tree, or they grow, but they don't give us cinnamon, or they don't give us anything. They're just there, and some of the trees under the tree, nothing grows under them because the leaves doesn't let other plants and indigenous plants grow. So it is like there's circle around them, and out where the leaves don't fall, everything grows normally, but under them nothing grows.
To add with Terence,
Thank
the
you so
pine
much.
tree is actually.
Ryan, can I ask a question?
Okay.
Guys, are you planning to correlate the tree height and circumference with another variable? Are you guys thinking to cross them with another globe protocol or something like that?
Can you repeat the question, please, because we didn't actually hear you quite?
Yeah, sure. The question is, if you are planning with the data that you already collected of the tree's height, if you are planning to correlate those or that data with another variable or data from another protocol or GLOBS protocol or other data.
I think maybe in the future, yes, we'll do something similar to that, but there aren't any plans on what to do exactly or something like on that lines. But I think yes, we'll take that as a consideration, but we haven't actually planned to do that.
Okay,
And
thank you very much.
To add with Ben, a lot of the projects are moving very slowly than other years because of the pandemic because we can't meet the whole group. So a lot is being done on the internet and stuff. But we will, like Ben said, we will consider it.
Thank you.
Hi, Brian. Good afternoon.
Thank you for joining us, Marilyn.
Yeah.
So,
I have another meeting on my other phone with my principal, so I'll be doing dual here.
okay, thank you. Anybody have any further questions for the students?
I just have one observation, Brian,
Yes.
which is that in my life, the Norfolk pine has always been an indoor tree, not the biggest tree in the neighborhood. So I'm shocked to hear the great size that can be achieved under the right circumstances. But well, that's one of the reasons we get together and talk, is to learn about other parts of the world.
Yeah, because our pine tree is actually quite different from the other pine trees all around the globe, because it has developed quite differently for some reason.
Excellent. Thank you. All right, so I'm going to go ahead and go back to the sharing my screen, and we will get to the trees in the news with Dr. Schumann. And let me go ahead and share my screen here again. All right. Are we ready to go, Dr. Schumann?
We are, Brian. Thank you for joining me on this virtual field trip. And remind me to get you an updated photo that actually shows how much gray is in my beard now.
I can add some color to it next time if you want.
I think I just need to really update that photo.
Okay.
That's okay. Memories being what they are.
Yes.
Here is a warm and humid area in Mississippi, part of the DeSoto National Forest. The U.S. Department of Agriculture runs the U.S. Forest Service and maintains and supports this particular environment. And so it's kind of nice to see it from above, seeing as that's how we get to travel these days. So this is all because of a news story which I picked up while just checking out what I'm looking for is basically interesting stories about trees that are in the news. And it turns out that there is this restoration project for this particular pine tree, which also creates a unique ecosystem underneath it. And as I explained to Brian when I proposed this story, I knew about what the longleaf pine needles created in terms of art. Next slide, Brian. But I didn't know about the tree. So that's a part of the learning experience of doing all this. So the upshot is there's a long history of these trees covering a large swath of the Southeast United States, from Virginia down to Texas. And because forests managed the understory, these unique ecosystems could be maintained and populated with really unique plants. But of course, humans doing what humans do, a lot of logging and clear cutting had largely eliminated longleaf pines and also their grasslands, where all these plants and animal species flourished. So finally, in these 9 coastal states, they're trying to bring them back, not just for their art, their ability to support indigenous art, but also because they are supporting all these different plants and animals that are literally found nowhere else. So they are now up to about 7,300 square miles, 1,900 square kilometers, with a quarter of that expansion since 2010. So this is something that's really kind of taking off. There's all sorts of nonprofit entities and government entities trying to support this, including the Forest Service, rescuing the longleaf from the dustbin, as it were. It's a positive story, which one of the reasons I like it. Note how much more area there needs to be restored, in contrast to what the original 1700s estimates were, is quite striking. It's orders of magnitude. And if you notice the elevation of the first image that I showed from Google Earth Pro, the elevation was given as 0. So I'm guessing that is one of the areas that was too wet to farm, thus becoming a national forest. But also fire suppression efforts played a role in the longleaf pine's decline, because fires are critical to getting the seeds to sprout and also to encourage their growth. So this is one of the awkward intersections between ecosystems that require fire and the people nearby who would not like to breathe the smoke or be threatened by the flames. So this is a balancing act. But it's crucial. Otherwise, other plants will outcompete and block the sun from the seedlings, the grasses, the wildflowers, the unique aspects of the ecosystem. Next slide, Brian. So as I mentioned, Indigenous art was how I knew about the longleaf pine, and there are some just beautiful art forms easily available for researching on this on the internet, or if you're interested, for purchase, because this is still supporting Indigenous people as well as artists who've learned the craft. But this gives you a sense of the height of the pine tree, 75, 80 feet, 25 or so meters high. And you can see the fire damage to the lower part of the trunk that is kind of essential to their survival and continued propagation. So here's the AP story, and is full of beautiful pictures. Next slide. This gives you a sense of both the pine trees themselves relative to some cars for scale, these are not fully mature yet, but they are getting there, and also the grasslands underneath that needs to be cleared periodically by fire to prevent other species from outcompeting the longleaf pine. Next slide. I really just can't fully visualize a foot-long pine needle, but here's a close-up of them, and the fact that they don't degrade is one of the reasons that the grassland and the ecosystem underneath them is so unique. So it is one of the things that also gives the baskets themselves their longevity, is the durability of these pine needles. Next slide. So here's a seedling in its very early stages, not looking like much, and one does wonder how it would survive a fire. But the upshot is that there's a method to how these plants have adapted to their ecosystem, and it's really nice to see humans taking an interest in bringing them back. Next slide. Gives you a good sense of the geometry of a tree, and how globe trees would be able to get a good estimate of the tree height if they were out in this area taking field data. And it's also cool to think about all the kinds of plants and animals that are growing in the shade of these trees. So next slide. 900 plant species found nowhere else in the Southeast USA. And I'm getting the impression from the rangers scratching his face that some of those include insects that bite. But there's just an illustration of one of the species, the gallberry, which is a plant that I was not familiar with at all. And this is, looks like a nice day out there in Mississippi. So there's another web link there that gives you some more insight on the threatened and endangered species that grow only in this particular ecosystem. Next slide. Here's the map that I promised. So you can see from the stars, that's where the forests are being actively restored, but you can also see by the historical range in kind of pale green how much of the Southeast United States that they covered at one time. And I guess it's going to take a while, and we'll see how far people can get. But this is just a reminder of the kind of change that can be induced by human activity. It's kind of dramatic, well, it's good to see people getting involved. That could be the last slide now. I think there's a growth cycle one. There we go. So longleaf tree life stages from the Longleaf Alliance. Things are not to scale, but the seedling stage to the grass stage to the bottlebrush stage to the sapling, where I guess by that point it can begin to resist fire more easily, into the mature stage. But if it's anything like the southern yellow pine, the wood is very good for woodworking projects, house construction, even furniture. So I need to do a little more work to explore that, to understand why these trees were harvested. Was it simply because they created land for farming, or were they really using the wood for construction and other human activities? I think that's it, Brian, and thanks very much for the time and for everybody listening.
All right. Thank you, Dr. Schumann. Anybody have any questions for Dr. Schumann and DeSoto and the longleaf pines? All right, so let's continue. So, Peter Falcon, have anyone from Philippines joined us yet?
Unfortunately not, Brian. It may just be too early for them at this time, which is unfortunate because I know on the 23rd, they're going to be doing a tree planting event there, and this goes in nicely with that event. I will keep looking at the chat room to see if anyone joins, but as of yet, no.
Okay, no worries. So what we can do is, we can have them present at the March webinar a combination of what they were going to talk about today, and then also the event that they're having very soon, kind of a combination of those two things. And we'll change the time around for them, which it'll be actually in waking hours. So maybe it'll be a morning one, Eastern time zone, so even a little earlier for the folks in Europe. So I think it'll be a little easier on the students from the Philippines. So no harm. So we'll bring them back. So no problem with that. So with that, we'll keep them on here though in case they show up. But if they don't, we'll just bring them back in March and potentially at the end end of year 3, when we have the larger workshop that we've mentioned numerous times, bring together lots of the students who have done research projects. So let's continue. So Dorian, let me pass it over to you. As I mentioned earlier, Dorian's going to be talking about StoryMaps, maps for beginners.
All right, well, thank you so much. And I am very sorry that our friends in the Philippines can't join us, but I'm going to be showing you the school where their data has been collected from. And what we're going to do, and let me see, Brian, do you mind going to the next slide, please, is I'm going to be kind of showing you some really, really basic tools for getting started with Esri StoryMaps. I'm thinking in this case of if you were going to be doing your IVSS report and you were going to be comparing and contrasting trees in 3 locations, and then because I support the Global Precipitation Measurement Mission, I would be looking at precipitation using the Global Precipitation Measurement Mission's data, and then comparing how much precipitation falls seasonally for each of these locations. So the 3 locations that I selected are my yard in Damascus, Maryland, because I know that very intimately. I chose the school that the gentlemen who were sharing today in Malta have been collecting their data from. I went into our globe visualization area platform, and I went to their school and I got a couple of pictures of the trees that they have been taking. And then I went to the Bodison Hills National High School, where our friends in the Philippines have been collecting their tree data. So Brian, if you'll click on comparing trees in 3 locations, I'm going to take you on in a video here that will show you how you can access this data. All righty, well, if all goes well, I'm going to be showing you how you can use the very, very easy map tools that come with the Esri StoryMap, and we're going to compare trees in 3 different locations. My idea with this would be that you could use data from the GPM satellite mission, which is measuring global precipitation. You can get that data for seasonal or monthly. In this case, what I would do is I would get the seasonal precipitation data, and I would compare and contrast trees in 3 different locations and look to see if the amount of precipitation that they're getting per season seems to make a difference in what the trees look like each season. So of course, what you'd need to do is you'd need to collaborate with a couple of schools. In this case, I'm looking at, if it was me collaborating with the St. Michael's Middle School in Malta, in Victoria, Malta, and the Bodison Hills National Secondary School in Quezon City, the Philippines. So I'm going to be showing you a very, very simple way of doing the maps. I have not done this investigation. This is just an idea. So I don't have that seasonal information, nor do I yet have the precipitation data. But I'm going to show you how you might, if you had all that data, create your map. So let me go ahead and share my screen. And I'm going to come over here and say that I want a new story. And I'm going to do a guided map tour because I'm looking at 3 different locations. As you do this, you can get a feel for what some of the different maps are like and how you can utilize them. Let's call this comparing trees in 3 locations. And we're going to be doing Damascus, Maryland, and we're going to be doing Victoria, Malta, and we're going to look at Quezon City in the Philippines. So one of the really fabulous parts of being a part of Globe is this ability to collaborate with different people around the world. Now, what I did here is, in this case, I have all ready to go on files here, some pictures of the things that I'm going to be putting pictures of. So one of them is going to be trees in my yard. So I'm going to go ahead and put that up there. So for my first location, I'm going to be looking at Maryland, and I'm going to be looking at, and I'm going to put here, since I'm not a school, Dorian Janney's trees, and add that this is in Damascus, Maryland. and put over here USA. Now, here's where using the story maps as the way to tell your story comes in really handy. There are so many ways in which you can utilize maps. I'm just showing you a very, very simple way today. And then next month, Peter Nelson is going to be showing you a much more challenging maps that you can use and ways that you can add different data and layers. So here you see I started to add my address. It came up, so I'm going to say, okay, super, super simple. I'm going to say add to map, and then I can pick how close or how far I want to zoom this. I'm going to go ahead and stay close right now for this. I'm going to say add location, but you'll notice that this map really just looks very boring. It doesn't really give us very much information. So I'm going to come over here to map options, and where I see select base map, I'm going to now click here. And now I have some different choices. You know, here I'm looking at the physical geography. That's pretty nice. I can come over here, and that's just, again, that just basic one. Here we're looking at you know, different colors, but that's not really giving us what we want to look at as close, you know, as well for trying to understand different types of trees. This one's not too bad. This one does kind of show us our kind of, you know, more of this geography and perhaps even topography. Looks like it's also showing us vegetation here. And getting a feel for if you're living in a city or not is very, very helpful. So I'm going to come in and close, see what that looks like. Yeah, it's still not exactly what I would really like to get a lot more of the overall landscape. So this is actually pretty nice here. And this one's adding some labels there. So I'm going to keep that. I'm going to say done. Over here I see the house. I can see that it looks like it's in kind of a rural or maybe suburban location. And indeed, that's right. So there, I've got that one. So the next one I'm going to do, I'm going to come over here. And because I knew that we were going to be hearing from St. Michael's School in Malta, I went and I found some of the pictures that they have taken of their trees. So I added one of those. So I'm going to come over here and write St. Michael's School. And again, that is in Victoria, Malta, on an island. So we're going to come over and find that. So I'm going to come here and I'm going to say, and actually I'm going to call it Gozo College, because St. Michael's School is a part of this Gozo College. I found that out by looking at the GLOBE program when I went and found this data. So I'm going to add this to the map, and I've already established that I like this zoom level and that I like this base layer map. So I'm going to stay with this. And then I'm going to add one more location. And this is, went on again like I had before. And I found that Bodison Hills has taken some pictures of trees. So I went ahead and grabbed one of theirs. If I was doing this as my, comparing and contrasting over the different seasons, I would, of course, ensure that I was picking tree images from different seasons. In this case, I didn't do that for just showing you how to do this, because I'm not doing an entire Ivss project. That would be a lot more detailed, but it would be a lot of fun. I would like to do it. So I'm going to add that location and then say add. And now let's, there's one other thing that I'd like to do. Come back here to the beginning and let's go ahead and see a preview, see what this looks like. So I can come here and here I am. I can come over here and I can click on this one, the first location where I live, and then I can come backward to get a feel for what are the ways in which this land is being used. And in this case, as I'd mentioned earlier, we see there's farms, we see it's suburban. As we come back a little further, we can see that it is outside of Washington, D.C., but it's definitely a very suburban type of an area, suburban or rural. So that gives us some information as we're looking through this and trying to get a better feel for, these trees and what some of the conditions are that they're growing under. So then I can come over here and now come a little closer to see, okay, well, this tree that's over here at St. Michael's School, what are the conditions under which it's growing? And again, I would also want to collect some precipitation data so I can be comparing and contrasting how much precipitation they get and getting a feel for how that also might impact the data. So this is pretty neat. You can come in close here. I would have the latitude and longitude when I look at the data for this specific tree, so I could even find which of these trees that it is. And I could even notate that using these tools, which is kind of a neat thing. So we see here it's on an island, get a better feel for what that's like. And then the last one, the Bodison Hills, I can come in closer to, come in closer to Bodison Hills, come over here to the Philippines. And for some reason that was not doing what I wanted to do. Okay, come over here to the Philippines and, nope, not you, darling. You, number 3. Maybe I just need to back it up. Because that's back in Malta. And come over to this one. Work our way over here to the Philippines. Come on. And perhaps something happened when I was doing this and I was clicking too quickly. I see I just didn't go far enough here, so my bad. So Bodison Hills, Bodison Hills National High School. Aha, add to map. Yeah, it always does help when you make that last step. So there we go. Now come back here to preview. And actually, before I preview, I'm going to say edit. I'm going to add a cover image, browse my files, come to my tree story map, and I have a picture of my granddaughter hugging a tree. I'm going to put that on because I'm crazy about my granddaughter, and I think it's nice to have pictures of people hugging trees. But you notice here that we can't see her hugging the tree. So I'm going to just move this little dot down here, and now it's going to focus on that part. And there we are. There she is hugging the tree. Now we can go down here and we can see there's the tree in Maryland out in the urban area. Here's a tree at St. Michael's School, and I can move back a little bit, get a better feel for what St. Michael's School is like. And then here, added my Bodison Hills. We see here also on an island and in a fairly large city as well. So I hope this is a help, just very, very basic, way in which you can go about creating a story and just getting in there and messing about with the maps a little bit. Next month, Peter Nelson is going to show us how to do some really awesome things with maps, but get in there and play with these maps a little bit so you can get a feel for what they can do and how you can add your images and find your locations, and then get ready for making it even more challenging. So thank you, Brian. And I know that if you want to, you'll have access to these slides and to that video. And, I hope you get in there and play with StoryMaps. It's just a super effective tool for not just making maps. And I've only begun to scratch the surface with that. That's why I deferred to Peter Nelson when it comes to really knowing how to get in there and work with the ArcGIS data and pull that in. But, for telling your story, for telling about your IVSS report, your story map is just kind of like, the next step of PowerPoint with the ability to be able to utilize it and share various things. So thank you.
Thank you, Dorian. That was great. Anybody have any questions for Dorian and StoryMaps?
Not a question, just a note of big thanks, Doreen. This was quite interesting. And initially I used to think that it's very difficult to develop a story map, but you have made it quite easy, and it's quite practical. And I'm sure students would love it. And telling them about trees will be very interesting for them. Thank you so very much.
You're welcome. And that was my goal, to show you how you can start off making it super easy so you get in there and play with it. You know what I suggest? Get in there and play with some of the pictures that you've taken while you're on travel, so that you're just kind of interacting with your own stuff, and then start to play with it. It's just incredibly powerful. So you're very welcome.
Thank you.
Anyone else? All right, let us continue. So my section here, here's an image. So I decided to do this image because I was actually working with a couple students from Italy, and they said about this cool area called Campo Basso. I've never been to Italy, but it looked like a cool place. So I was working with them, and it wasn't directly on this project, it was with another project I work on. But I decided to go and look at some satellite imagery of this area. And you can see here, I found the latitude and longitude basically of the town center. But my question here is, and this is for student research, how can we take an image just like this, look at it, and what can we tell about this image? What can we tell about the tree cover in this image? It looks like a pretty urban area. I mean, there's lots of buildings, lots of sidewalks and streets, lots of brick and mortar, as we call it. But we do see trees, and we see a park here. Looks like the fountain, Fontanella. Looks like there is that. So what you see here is, what you're looking at here is this town center called Campo Basso, Italy. And the red arrow that you see there is the location of a tree, one of the trees that was measured by some citizen scientists using the NASA Globe Observer Trees tool. So, but before we get into that, just think about this. You don't have to answer. You can put it in the chat, and if if you want to talk amongst yourselves in the chat, when you look at this image, what can you tell about the tree cover? What can you tell about the land cover in this? What type? It's hard to tell exactly what type of trees, but and what about the greenings? Can you basically tell? It's in Italy, so you have the latitude and longitude. What can you tell about the greenings? Meaning, you see there's leaves on the trees, the pine needles are green. Okay, so what season could you say it was? And you can really tell a lot. And this is hopefully some people will understand that you can do research projects just by looking at an image like this. You can find an image of your location around the world, and say, hey, this is what it looked like. Say you have an image from 1935 or something, and then you have another image of the same location in 2021. Okay, you can do a lot with that just by looking at these two images. You can do comparisons, you can do contrasts, you can look at how the land cover has changed over time in that 90 years, 80 years, 90 years. You can look at how many trees, are there a lot more trees or a lot less trees? I would probably say there's thinking about that, there'd be a lot less trees because of all the buildings being built. And then was it taken at the same season? Greenings might be a little tricky. You'll just have to be able to look, because back then it was primarily black and white photos. So, but you'd be able to see if there's leaves on the trees, not necessarily what color they are. So it might be a little tricky, but you can tell a lot by looking at images like this. So here's what I did, and I have a video to showcase that on the next slide. But I went and I found that location in the Globe visualization system, and I've these top 3 images on the left, basically showing you in Italy where this location is, and then zoom in a little more, and then zoom in even further. And then these are a couple questions, a couple investigative questions that you can use to help guide your research. What can you say about the land cover in this area? What can you say about the trees in this area? Can you find globe data from this location? Can you find ISAT-2 satellite measured tree heights in this location? Okay, so then what you're looking at here on the far right, this image that kind of looks like the ones on the left, but this is from Open Altimetry. So the base map you're looking at here is from Open Altimetry. okay? But what you see there, and we've talked about this before during webinars, what you're seeing here are these photons. Remember, ICED2 uses a laser altimeter system where it bounces photons off the planet. So we take the time, we calculate the time it takes the laser photons or LiDAR to leave the satellite, bounce off the Earth's surface, and come back again. And by measuring that time and doing that repeatedly, we're able to tell how the elevation of things on the Earth is changing. We can measure the height of things all over the planet, okay? So what you're seeing here, the pink and the purplish dots, those are photons that actually left the satellite, hit the Earth's surface, and came back again. Now, we have ones that hit very close. They didn't have to hit the exact tree, and that's something that is really tricky, to hit the exact tree, but it hit an area just next to the tree, just adjacent to the tree, where there's also other trees, and we got building heights and everything. But what you're looking at here is this little graph on the bottom. This is from Open Altimetry, and it's showing you the tree canopy height, the average tree canopy height for this location. Because remember, when you're taking the exact measurement of a tree with a NASA Globe Observer, you're taking one tree observation. ICED2, when it sends the laser photons down to the ground, the laser pulse spreads out and you get about a return of about 14 meters. So meaning it's basically calculating that average for all the trees that fit within that 14-meter diameter footprint on the ground. So if you have a tree, if the tree that you measured was isolated and there was nothing within 14 meters, or basically 7 meters radius outside of this tree that you took, it would return just that tree height. But if it hits an area where there's lots of trees, it's going to take basically that average of all the tree heights in that location, in that 14-meter diameter space. So I'm going to play this video for you where I'm showing you how, as a student and as a teacher, you can go in and grab the data from a map, even like Google Maps or Google Earth, and then the globe visualization system, and then as well, then look at the ICED2 data for Open Altimetry. So then you can take all that data and compare it. So here, let me start this now. Let's say you're given an image like this. This happens to be an image in Italy. And what if you wanted to do a student research project to determine what you can tell by just looking at this image? What can you tell about the environment? Basically, what can you tell about the trees? What can you tell about the land cover? Is this an urban environment? Is it a rural environment? Is it a suburban environment? What can you tell about the seasons based upon the latitude and longitude of this? Now, I happen to know the latitude and longitude of this area. But what I want to do as part of this research, I want to show you how you can just look at the globe visualization system and see if there are any tree height observations taken in this location. And then we can look to see if there are any NASA ICED2 height measurements in this location as well, using the Open Altimetry online tool. So we're starting with this picture. You know, at first you can say, you know, you can have a hypothesis. Well, I think all the trees here look like they're between, 20 and 25 meters tall. It looks like there's an urban environment here. And it looks like, it may be springtime or summer because there's lots of green in the trees, in the grass, in the vegetation. So that could be a hypothesis. So, we can expand upon that by looking at some more data. So let's jump to the Globe website, okay? And we're going to go to, under Globe data, we're going to go to visualize data. That'll take us to the Globe visualization system. So let's do that. So once we're in there, we're going to go first to this fourth square up top here with the 3 dots. And we're going to change the base map to satellite. Not streets, satellite. So here we have satellite map. And then we're going to back out of that and go to these 3 layers here, the far left square. We're going to go under biosphere, under tree height, and let's just click tree photos. Now, while that's loading, remember this first picture was of Italy. So we're going to find that location. I happen to know where that is once again. And if you have taken a tree height observation in areas, you will be given the latitude and longitude of the tree location. So I'm going to zoom in here to Italy. all right? And the location that you see on this is going to match up with this image right here. It looks like a tree height observation from this area. So we're going to zoom in. And you can see this right here. It falls within this area that we're looking at, okay? Now, what we want to do here is we want to look and see where this tree is, okay? You can see on the map where it is, but if you click on the actual photo, you're going to get this information. The measurement tab will tell you what the height of the tree is. This happens to be 5.17 meters, okay? And then you have some comments here where it was. Villa Piazza Vittoria Emanuele, okay? That's the location that was put in by the observer under metadata. You can see there's several data counts here. And then we're going to go in site info, and that's where we get the latitude and longitude. So once we have that latitude and longitude, we can then go to the Open Altimetry page and put that information in. So we go to Open Altimetry, that's openaltimetry.org. Going to click on the red rectangle that says Browse ICET2 Data. And on the left side, you can exit out of this. On the left side, you can see there's an arrow just below the magnifying glass. Click on that. And then you see center map on a point where you can input the longitude and latitude. So if we go back to the globe visualization site, and we're going to highlight the longitude first, copy that. You don't need the degree symbol. Go back to Open Altimetry, paste that in longitude, and we go to the latitude, do the same. Go back in Open Altimetry. And then we click Update Map. It'll center that location on the map. And if we go up to the top left, we can use the plus button to take us even closer into that same area. But what you'll notice here is that these red lines are ICET2 orbit tracks. These are important because this will tell us if ICET2 was near the latitude and longitude that we're trying to look at for tree height. So let's zoom in, and we'll click on one of these. Okay, remember, center of the map, the center of this map you're seeing here is the location you want. So we click on this orbit. We can click on these dates. We can see that ICET2 has been here. So we click on this one. No, that's not that close. Oh, here's one that's very close, right here. These pink and purple dots, these represent photons from ICET2 that have measured the height in this location. So let's exit out of, actually, let's zoom a little further here, okay, to where these dots are. Make sure we update this map and keep it centered. Update the map. All right, you can see here that we're very close to the tree that was measured in globe. So let's back out of this. And what we want to do here is we want to go up to the top left under Open Altimetry where it says Select a Region. Click that, and then you can come over and you'll see this hatch mark or this plus sign, and you can hold the mouse down and drag a box around this area. Now, it doesn't look like the exact tree was measured, but there are lots of tree height measured in this location. So you can help, understand and focus on your hypothesis from this original image based upon what you see here. So let's click on View Elevation Profile. So what we're looking for are canopy heights. The top part, what you see are the elevations, the ground elevation and canopy surface. So what the elevations are for the area you're looking at. But then we'll see canopy heights. And each one of these photons here represents a tree height that was measured. So as you can see, there's been a bunch. So remember, in the original latitude and longitude from globe, let's look at the latitude, 41.5574 degrees. Let's see if we can match that up on Open Altimetry. Here we have 41.555, getting close, 556, 557, 557, okay? Here we have some that are very close. So let's click on this one here. We'll scroll over it. You can see canopy height for here It's a little taller than what we saw on globes, so it's not the exact tree. But you can see the latitude is very, very close, 41.5573 to 41.5574. So very close. So it's a tree that is very nearby. So based upon that, you can then look at the tree heights for this area. You can see if your hypothesis was correct. You can then use all this information to look at this image even closer from the original image you see, and then any images you can see on open altimetry, and images that you can see on the NASA, the globe visualization system. And by combining the information that you get from all these images, you can develop a research project explaining how you can look at images on 3 separate systems to determine what that local environment is, whether it's an urban environment or a rural environment or a suburban environment, what the tree heights are like, what the land cover's like, what the greenings are based on seasonality. So I wish you good luck. And this is just one way that you can look at doing a student research project as part of the Trees Around the Globe student research campaign. Thanks so much. All right, so I hope that was a fun little explanation into how you can use these 3 different examples from the the globe visualization system to just looking at a simple map like on Google Maps or Google Earth, and then also the open altimetry data. And that's one of the things that we like to do at NASA is we like to try to figure out what's happening in a local environment to understand the global picture, but by looking at a combination of the ground-based data done by citizen scientists, done by researchers in the field, okay, professional researchers who, write papers, do research, things like that, and then compare all that to like the satellite data, specifically from ICESat-2. And there's lots of other satellites out there like Landsat and Aqua and Calypso looking at clouds. So there's lots of other, CloudSat, lots of other different satellites out there that are doing these things. So that's one of the things we like to do. So hope this helped out a little bit for this. It's pretty easy to do, pretty self-explanatory. Does anybody have any questions on this part?
Hey, Brian, you do have one question in the chat from Anna. Yeah. Right before you got to the graphs, there's one point where she's asking, what do the different colors of the dots represent in open altimetry?
Yeah, so the dots, Anna, the dots are the actual laser photons. So when the ICESat-2 fires off the photons at 10,000, well, the fire laser pulses at 10,000 times per second, okay? What those colors represent in those 10,000 laser pulses, there's photons, since it's lasers, light, okay? The colors represent the photons that are hitting. Now, they're just different color coded because essentially there are 6 beams. There's actually 3 beams from ICESat-2 tracking at a time, but each beam is split up into a pair. So it comes down to it's actually 6 beams. So each beam pair has specific, color-coded colors on open altimetry. That's just how we reference them. They're the different satellite beams representing the photons that are coming back from ICESat-2. And these photons are what we time leaving the satellite, bouncing off the Earth's surface and come back to the satellite, so we can then determine what the height is of whatever it measured, whatever that photon hit and then came back to Earth. That's what the colors represent. All right, so let me go ahead and move on. And next we will have Peter Nelson. He's going to be talking to you about the importance of online tools for student research and how do you know which online tool to select. And Peter, I will go ahead and stop sharing and take it away.
Thanks, Brian. I know that we've covered a lot of details today, going through and showing you a lot of different ways of looking at Earth from space, from the ground, using images versus using laser beams, all kinds of graphs. And so I just want to take a moment here and remind everybody that we do have some videos and other resources available for you based off of what we've done. And so definitely go back and review some of these tools in particular that we've shown to you. I just want to take a moment here and open up and see if there's any questions about some of the things that we've shown related to this. We know everybody has different research questions, and sometimes those lead to different tools and ways of getting data or viewing data. And I do want to remind everybody that, you know, Globe has many lesson plans and other resources that you can help to use to frame your research or for your students. And so we've been highlighting some of the newest that are out there, but you know, Globe has been doing this for 25 years. And so, you know, that's one of the challenges that we have, is just sifting through all the great things that scientists come up with and computer scientists come up with. And we want to help guide you and help you make efficient use of your time. So I know there have been some questions, and I think we've been able to answer some of those in the chat. But here, I just wanted to stop and see, do people have any questions or kind of general questions or things that we might be able to guide you towards as you consider how to connect your ground observations to some of these satellite data or this other data that might be useful in your own research projects?
While people are thinking about their questions, Peter, I will share my screen and go to that online tools section so you can remind them what's all up there.
Here, Brian, I actually have that up myself.
All right, perfect.
So again, you know, we started and went through a variety of these, and you can find them on the on the website. And Brian has done a great job of parsing out from our hour and a half long presentations, and really help to guide you to specific tools that are out there. And so I think, you know, this is one place where you can start to understand this. I've also, you know, based off of what we've been talking about, I really want to point everybody to what Brian just showed with the Globe visualization system and the value of going to this location and turning on that satellite view, choosing a different base map so that you can actually see that satellite view of Earth. Now, cloud free, so if you're working with clouds, this may not be very useful, right? But if you are wanting to explore, you know, and see like the longleaf pine that we were looking at earlier, you can just zoom in on this on this area. And I thought this was very telling right here, where we can actually start to see some of the patterns that people have created in these areas to both restore and work with that type of vegetation. So for me, this Globe visualization system is just a really good place to start and have your students starting to connect this aerial view to some of the data that's available within that larger Globe database that's there. And like I said, you know, why are these long rectangular shapes? That right there is a great research question. That works perfectly in this time where some internet research and some other ways of knowing, not just those field measurements, might be able to provide some insights. And Dr. Schumann has really highlighted how doing some internet research can really help ground your work in understanding what's out there. You know, you can just also access the recent imagery by changing some dates, right? And you can actually start understanding and seeing different dates in time if you change your resolution a little bit. And so I'll just mention that I think one of the things that can be really hard for students to understand with this is there's no dates, right? What are you actually looking at? What's the satellite and what are the characteristics of that satellite? So I just wanted to encourage everybody to be aware that as students are putting together their research and maybe using some of these tools, a good researcher understands what they're actually presenting. And that means date, the instrument that was used, and also providing proper credit for these things. And so there is very few things called a Google image. Usually those are actually some type of remote sensing that is out there with an instrument. And so that's a great place for your students to get in and start to understand and see how to cite this type of information. So that's one of these great pieces that I think is part of this research that we want to highlight. You know, and this is one of the challenges that we all have in this digital age. Sometimes just going in and clicking on that bottom layer will take you to what Globe is presenting to you and with the information that is available that we're seeing. And we want our students to better understand how this data is created, who, and the time frame that it's referenced to. So, you know, for me, you know, these great, wonderful tools that Globe has put together, analyzing these the Globe data, it actually provides a nice framework for students to actually go through and do similar activities as what Brian highlighted. You know, this idea of if you can't go out and do a real land cover sample location to understand the context of your tree, remember, you can use these tools that we're presenting to do a virtual transect or do some virtual understanding and do that in a systematic way. And that's a really important key to remote sensing. And I think right now, this is one of these opportunities that our students are getting the chance to understand field work in some cases, but also the importance for good documentation and how it comes together with some of these virtual activities that we can make use of. So for me, you know, these are some of the great tools that are out there. I want to highlight that NASA has put together, along with some of our other collaborators, an easy way for you to enrich your data set with satellite data. And I will be doing a more in-depth tutorial of this tool right here. But once you create a profile, you can actually put your latitude and longitude in there and get information like surface temperature from some of the sensors that are on the International Space Station, for instance. And so, you know, I fully understand that there's a challenge of trying to sift through all of this information and help students provide context to these globe measurements that they have. But that also provides us opportunities to teach computational thinking, data literacy, and some other pieces that the data alone might be missing in there. So that's what I wanted to highlight today, and we're here to provide guidance and help, and would be willing to, you know, meet with students or meet with you one-on-one if you have specific questions on this. And so, you know, take advantage of the 5 people that are on this team. Get in contact with any one of us, and we will help get you the information and the data that will make your students successful as they race towards their deadline for submitting to the International Virtual Science Symposium, or just in other activities that you have going on within your classroom. So we're here to help and hope that some of the deep thinking that we're providing to you through just looking at these satellite images and the ground images can provide really good investigative questions that start with just starting to deeply look at your environment around you. So I hope you come back and next time, and we will dive deeper into bringing these maps into StoryMaps so that can be part of what your students present. So thanks very much for all of your attention today, and I hope it's been well worth your time.
Yeah, thank you, Peter. Anybody have any questions for Peter? We have one more thing on the webinar, even though it's 3:30. We're going to quickly go into some last minute questions here that have popped up, you know, prior to the webinar. So I'm going to go ahead once again and share my screen. We have 5 of them, so and we can quickly, you know, whoever wants to take them on our team, or someone in the community here, and one of the participants wants to look at it as well or mention some things on it. I'm going to go ahead and share my screen and go back into that right now. All right, so. All right, we're going to do student research campaign Q&A session. Peter is going to lead this. And here are some of the questions that came up.
Thanks, Brian. So from one Peter to another. Very quickly, here are some questions that we came up with that we thought might help teachers and students with their IVSS research. Also to help make those connections from one variable to the next. So here are some of the things that we've came up with. So I'm going to go ahead and read them off. The first one is, could students in elementary school use the tree height protocol to do research for an IVSS investigation?
I can go ahead and take that if you like. So absolutely. Definitely to do the tree height protocol, whether it's the classic globe one using the handheld clinometer, which is fun for all ages to build. My son built his first one when he was 11. He had fun doing that. Or using the app, since it's elementary school, we want to definitely have to use their parents, accounts, because ages basically 13 and older to have your own the Globe account. But this is cool because, an IVS investigation is not always dependent on how complex it is. And we know in elementary school, some of the complexities can get troubling as far as trying to get too scientific. But think about, what some students in elementary school ask, what type of trees are those? Why are those trees green? Why are there trees here? That type of thing. And they can just, what type of animals are living in the trees that I see outside my window? So by looking at the tree height, they can basically, then go and do some research figuring out, well, I took tree height of 10 trees in my backyard, now I have pictures of them. So now I can do some research online or in books to identify what these trees are. So a research project for an elementary school would be, what type of trees are in my area? And then you can figure out, as you can go further and further, into the question saying, well, why are these trees growing in my area? For instance, we heard about the Norfolk pine earlier, from Malta. We weren't expecting to hear that about Malta, having a Norfolk pine, which was the tallest tree, in the study area that they did. That's surprising. That's the type of thing that, inquisitive minds like elementary students will want to know and find out about. So yeah, definitely it's a using the tree height protocol is definitely that starting point for digging deeper into all about trees in your location and land cover as well.
Hey Brian, I might throw out too, having been an elementary school teacher for almost 2 decades, that we studied seasons a lot, and even getting into climate in elementary school. If you're in the United States and you look at the next generation science standards, you'll find that there's so many ways in which you could have students using their observations and not just the tree height, but also what do they see, what kind of leaves are on the trees, and getting a feel for greening up and greening down. All kinds of rich opportunities with the tree height tool for elementary school.
Thank you, guys. Our next question is, what are 2 really good protocols to pair with the tree height tool to conduct research for an investigation? And Peter, I want to give you this question because this really leads into a topic we discussed last week when we talked about protocols being a system and not just kind of one-off things, but really see it as a system. So I was hoping perhaps you can answer that question for us.
Well, thanks for that prompt, Peter. Yeah, for me, if you recognize that you have a tree, you've already started down the path to doing land cover. And you've already actually classified something. And so in fact, you should be pairing or thinking about, like what we were showing earlier, that tree in context. Are there buildings around it? Is there grass around it? Is there water around it? And so actually pairing it and really putting it into that context using the Globe land cover protocol, where maybe you measure. It's a great activity because you can actually space students out on a grid, and that way they can be far enough apart, but you can actually put that tree that you're measuring in context. And then when you go and look at it from above, from space, it has even more context. You actually can understand that tree and what's around it when you're looking from that satellite view. The big piece that I'll talk about with that is that tree height is the structure. That is the Z part of Earth. And a lot of what we first need to do is figure out where the location is on the ground, where these are actually situated. So to me, land cover and tree height are just integrated. They really should be thought of very much together. And then importantly, bringing in cloud cover actually and doing the cloud protocol is a great way to think about how much sunlight might that tree actually be getting. And could it be blocked by those, by the buildings around it? So in fact, it may only get sunlight during, you know, between 10 a.m. and 2 p.m. And so, you know, land cover really helps to provide some context. And then when you start looking up into the sky, you can actually start thinking about those important parts that drive photosynthesis, and that can really be part of that process. So something as simple as cloud cover and looking at the sky conditions in relation to the land cover and tree height. They're, to me, clouds and land cover really complement tree height significantly with this. And one thing we haven't talked about is tree height, but what about the canopy? Right? As Dr. Schumann was showing earlier, we couldn't actually see the ground because of the width of those trees. And so, you know, that all comes in back to the land cover protocol as really complementary tools that help us to understand the satellite view and what's on the ground. So those are my suggestions. Add land cover and add some clouds to provide that context to your tree height measurements or estimates.
And I'd throw in there, do precipitation too, because of course, trees are definitely impacted by too much precipitation or too little precipitation. And also remember to throw in elevation and take a look at the impact of elevation and, you know, even kind of some of your surrounding surface features.
And Peter, what you mentioned about the trees not, you know, some, you know, may not get enough sunlight, you know, or certain sunlight during certain times of the day. It reminds me of in our front yard, actually side yard, next to the driveway, on either side of the driveway, we planted crepe myrtles, and they were both the same size. They were saplings. They were very small. They were about 1 meter tall when we planted them about 8 years ago. And we weren't even paying attention to how much shade the one area was getting versus the other, even though they're only about 30 feet apart. But one is definitely has a stunted growth. So that one is in basically sunlight for maybe 4 hours to 4.5 hours a day. So it's definitely a lot smaller than the other one, which has gone crazy. So it really, really makes a difference.
And Martha in the chat also wanted to point out that tree orientation would be a good variable as well. So moving on to the next question. One of the best aspects of the GLOBE program, I think we can all agree, is collaboration. The ability to collaborate with other schools from other countries. So that brings us to the question, what would be a good investigative question to use for collaborating with another GLOBE school?
So Peter, this is actually a perfect thing. I'm going to put into the chat because there is this, that document that I just showed you up there is all about investigating land cover in another location. And how to use the GLOBE visualization system to go through and compare and find another location that has either the same land cover types as you, or find an area that is very distinct from you. So if you're able to find a lot of trees in your area, you might record the latitude, longitude of your site. But then you might go and use this nice document to guide you through finding another location for an area that has no trees in it. What is the latitude and longitude of that location and elevation? You know, that to me is a great way to find other places, other schools that might be interested in collaboration, but also make use of that data to help put in context maybe why you are actually finding trees and the type of trees in your location. So I'm really glad that GLOBE has some of this framework to help guide that collaboration piece with it. And sometimes just going in and exploring that data is a great way to just visually see that place looks different than my place. Now, why is that? And so having those photos, whether they be the tree height or whether they be the land cover, is a great way to just visually look across and see, this place looks similar to me. And why is that? Latitude, longitude, elevation, a lot of times drive that.
And if I may, as we heard from Malta today, that sometimes trees are removed from particular areas. And so one of the things that I think would be interesting to do is for all the schools to sort of document their history of doing this kind of study. And you can find schools that are similar to yours, starting out perhaps, or you can find schools that have been doing it for a long time. What have they learned along the way on how to do this in their particular area? Sharing those stories, I think, would be a great way to start collaborations.
Thank you, Christopher. So our next question, I think we had a really good presentation earlier today on the story maps by Dorian. So the question is, how can we use story maps in our IVSS reports?
I'll jump in first on that one. And I'll tell you today, Brian Campbell shared with me a couple of StoryMap draft reports being generated by some students in the Netherlands. And what an effective storytelling tool. You know, even once you get in there and you know, interact with the maps, of course, there is just so much that you can do. But even using it to share your pictures, talk about your investigative method, show some videos that you took while doing your investigation, show where you are, you know, geographically located, include some links that somebody might go to learn more. Just a super, you know, user-friendly, engaging tool to use to get people involved in your story. And you know, let your students go into story maps and play with it. They are, you know, so good with technology. And, you know, as a former educator, I would say, you know, let the kids get in there and do stuff, and maybe even give them a few tasks and let them even share what they've been able to do, because I'm sure they will amaze you. It's incredibly what I would say user-friendly. It's fairly intuitive, and especially, you know, for students that have some really, you know, good computer skills, I think that they'll get in there and just go crazy. And there's tons of tutorials for those that have the time, energy, and attention span to do tutorials.
Anyone else like to add anything to what Dorian mentioned? Good. Okay. Well, let's go to our final question. Another good thing about the program is 25 years worth of data and database. There's a lot of variables that we can choose from, which leads to lots of questions. And we understand that all these variables, all these questions can get confusing on which one would be best to use. So the question is, where can we find some good investigative questions which we can answer for our IVSS investigation?
So what I'll do is I can start with that one, Peter. And you know, as I'm going to get out of this and go to our campaign website, because we have some questions up there that may be used. But also, you know, the third question there said, you know, how can you collaborate with other Globe schools? You know, maybe, you know, communicating with other Globe schools is a way to brainstorm good investigative questions that fall along the lines of how to collaborate. You know, they're talking about the latitude of the locations. You know, if there are trees in different countries but at the same latitude, why are they there? You know, why are there some, you know, at the latitude in some of the countries in Europe versus the ones in the United States? You know, why, if the students see the same trees, you know, that's the top. Why are they there? Or maybe it's the same latitude and two different locations and the trees are completely different. So that's a type of question. So let me get out of this and go back to this here, to our webpage, and we will go to we'll go back to this here. All right, so right here. So as you know, we have this, you know, this overarching research question, the thematic overarching research question which is the real big question. You know, why aren't there trees in my local environment? That's the big question. You know, that's a tough one to answer. So these investigative questions, or we also like to call them exploratory questions, are ones that are smaller questions that can be, you know, you can look at data, you know, look at research, you know, do online investigations, look at online tools to help you come up with answers to these smaller questions, these exploratory or investigative questions, to help answer this larger question. But as you can see here, here is a list of just some examples of these type of questions. And I'm not going to read every one of them, but you know, where are all the trees in your location? What is the tallest tree in your location? What type of trees are around me? You know, what is the elevation where we don't see trees anymore? That's kind of tricky. But if you live in an area like a mountainous region, you know, what is that level that you start seeing the trees disappearing? Okay, I know last time I was in the Rocky Mountains in Estes Park, Colorado, it was just, there was this line when it was just trees to nothing. And it was almost like going on to a different planet. It was like leaving Earth and going to Mars or something, because it was just a totally different environment. The biome change, you know, all you saw were a couple grasses, couple graminoids, and that was it. But just, you know, 100 to 200 feet lower, there were these massive pine trees. So, you know, that type of thing. Look at your environment. So there's lots of questions here, lots of example exploratory questions and these, of course, this isn't an exhaustive list. Lots of students have a lot of great ideas, you know. We never want to sell students short when we say that it might be hard for them to come up with research questions. They'll probably come up with research questions that we who work in this type of stuff all the time don't even think of. That's one thing that when I talk to some scientists, you know, who work with ICET2 and some of the other missions, that the scientists come together and say, what questions can we answer, you know, using this satellite? And then when the satellite gets into space, you know, so many other questions open up, you know, like, why didn't we think of that? So, but yeah, this is why it's important, because, you know, answering a question will, you know, investigating a question, exploring questions, and you know, figuring out what the answer to those questions are will bring more questions and then help you to get to that big question that you want to answer in a research project. Anyone else like to add to that?
I think that was well said, Brian. And that is exactly why we wanted to provide this overarching question. Why are there trees in your location? And sometimes it's a really simple answer. People planted them. And then there can be some questions maybe about, were they successful at planting? Why did they choose the species that they did? Like we heard about from Malta earlier, maybe that's why they have some of these non-indigenous plants there, right? So it's I think what we really wanted to provide similar questions as what people who are working with NASA research or getting funded by NASA, these are the type of questions that they have been asking for 50 years, ever since we put the first satellites up in space. Where are trees located? And that is a fundamental part of just mapping the Earth and the resources of Earth. And so it may not sound like a sophisticated question, but in fact, it really is. And how do you recognize a tree versus a shrub versus grass? Again, you've already started doing classification when you think you have identified a tree in your area. So I'm really glad that you brought this up and brought this back to some really easy, relatively easy questions, but that might have very different answers depending on where you are in the world. And so, you know, let these kind of guide some of the ways that students can think about their environment, and the way that it can guide them in a way that many scientists are trying to propose to NASA. This is what I'm going to research. Where are the trees located and why are they there? I mean, that's a very fundable research project if you bring in why you are asking that question. And so I'm really glad, Peter, that you brought up this idea that there's 25 years of globe data. And, you know, Dr. Schumann, the whole idea of going back to, you know, what people have done in the past, that is a great place to start as well. So you don't have to, you know, start with nothing. We know something about Earth. We have had past research, and let that inform some of the way that you go about your research or some of the questions that you might ask.
Thank you. Brian, I love the way how you point out, really, this is just a starting point for students. This is something they can build off of and really make their own and add to this list of questions as well. So with that, I want to turn it back over to you, Brian.